Hello, wonderful students. Thanks for joining me in my office today. We are going to be looking at reviewing ionic bonding here. So I'm assuming it's been a couple weeks since you did this, but I mean, who knows? You've probably kept up with chemistry every day. But just in case, here's going to be a video lesson on reviewing ionic bonding. So with that, if we take a look here, at ionic bonding, first thing we need to review is what is the difference between an atom and an ion. So if we go ahead and just recap on this really quick, and I'll try and keep my explanation short, let's use oxygen as an example. So if I look at my periodic table on oxygen, I can see it as 8 protons. So what that's going to mean is that inside of our nucleus, there are going to be 8 protons, and we won't worry about neutrons here. And then on the outside, atom would literally mean that, and I'll include the definition, it means same amount of protons and electrons. So that would just mean that, and remember your first energy level can hold 2 electrons, second energy level can hold up to 8, but in this case, since definition of an atom is same amount of protons and electrons, oxygen has to have 8 protons. So therefore, it also must have 8 electrons. So if I draw that out, this is an atom. What an ion means is after it has gained or lost electrons. So remember that oxygen is going to gain 1, 2 to become like a noble gas. So if we remember like our game of ions, this would mean 8 positive charges, 8 protons, 10 negative charges now, because you have your 10 electrons, so charge of -2, so that would make it an ion, right? More specifically, this would be an anion, like an antagonist, the negative person. So ion means different amount of protons and electrons. And another important thing to remember, protons can never change, right? Protons are going to be stuck inside of this nucleus here. So your number of protons will never ever change. So we can add in a little side note here that this specifically gains or loses electrons. Okay, coming down to question number 2. Element is going to be an ion. So in this case, we have sodium. Well, if we use our periodic table, sodium is right here. We can see it says +1, so we can use that shortcut, but it's important to remember that that +1 comes from sodium wanting to lose 1 electron to become like neon. So if it loses an electron, protons are now winning. Therefore, sodium is a +1 charge. If we look at oxygen, and we actually just did this above, oxygen is right here, so it could either lose 1, 2, 3, 4, 5, 6 and become like helium, or oxygen could simply gain 1, 2. Since it's going to gain 2 electrons, and electrons have a negative charge, this would be O - 2. And you saw that happen up here. And that's also why if we look at sulfur, sulfur wants to gain 2 electrons, so sulfur is also going to be a -2 charge. If we look at the magnesium, fluorine, and nitrogen here, we'll just start to speed this up. Magnesium is right here, and it has a +2 charge. So we just write Mg +2. If we look at fluorine, fluorine on our periodic table has a -1. So we would write F -1. And then nitrogen is a -3. So we'll just write N -3. And that is our ion charges. Number 3 is just a quick reminder here of how to count atoms. So if we see CaBr, what that again means is 1 calcium. And I'm not drawing a loose dot structure right now, I'm just simply representing the atoms bonded to 2 bromine. So therefore, if I fill this out, 1 calcium, 2 bromine, 3 total atoms. If I do the next one, it says gallium, GaF3, 1 gallium, 3 fluorine, 4 total atoms. Next one, notice we have this this coefficient out front. So the way that I always look at these is let's actually just focus on this highlighted part first. So we're going to focus on the Na2O. Well, if we do that, what the Na2O means is 2 sodium, so Na bonded to Na bonded to O. That 2 out front literally means 2 of that entire thing. So if I draw another one of it, well, now if I count, I have 1, 2, 3, 4 sodiums, 1, 2 oxygen, which gives me a total of 6 atoms. So that's all there is to doing those ones. If we do this next one, and what you could see here is really what this 2 did out front is it multiplied everything. So to use a shortcut, there's this hidden 1 here by calcium, so 3 times 1 is 3 calcium. 3 times 1, because again these are capital letters. Remember, every time there's a capital letter is a new element. So 3 times the 1 carbon gives us 3 carbon, and 3 times, and we can see that 3 there on oxygen. So 3 times 3 actually gives us 9 total oxygen, which then gives us 15 total atoms. And so we're good on that one. Remembering Lewis dot structures, well, it's nice because I actually gave you the same problem up here, CaBr2. So right away with this one, we're actually off to a good start in terms of being able to be like, okay, I know there has to be 1 calcium, 2 bromines. Just remembering your Lewis dot structure now, we need to remember our valence electrons. So that's that shortcut, our shortcut we learned for electrons on the outside. Calcium we can see has, and remember our shortcut is 1, 2, these all have 3, 4, 5, 6, 7, and 8. So therefore calcium has 2 valence electrons. So I'm going to draw those on here, 1, 2. And remember, calcium is trying to actually lose electrons to become like a noble gas. It's going to lose 1, 2. If we look at bromine is right here, so it has 7 valence electrons, so I can draw each of these bromines with 7 valence electrons. But each bromine is trying to gain 1 electron to become like krypton. So I actually know right away calcium wants to lose an electron, so it'll transfer 1 to bromine here, transfer 1 to bromine here, and actually that one looks pretty good. Calcium's happy it lost the 2 that it wanted to, leaving it with a +2 charge, and each of these bromines is happy because they each gained 1 electron, leaving them with a -1 charge. If we come over to this next one, gallium fluoride, what we can do on this one is it's a little bit of a reminder, but we're going to break this one down. And let's draw our gallium. So gallium is right here, so it has 3 valence electrons. So I'm going to draw my gallium. 1, 2, 3 valence electrons. Fluorine has 7 valence electrons. So I'm going to draw my fluorine with 1, 2, 3, 4, 5, 6, 7. And now I don't know this formula yet. So I actually need to figure it out. So gallium wants to lose 3 electrons, right? It could either gain 1, 2, 3, 4, 5, or it could lose 1, 2, and 3. So gallium wants to lose these 3 electrons, so it'll transfer 1 to fluorine here. And then we just simply ask ourselves, is gallium happy? No. Is fluorine happy? Yes. Fluorine gained 1. All right, well, so what has to happen? Gallium's going to find another fluorine to bond to. Transfers 1 here. Is gallium happy? Nope. It's going to find another fluorine. And gallium can transfer 1 there. And now everything's happy. Gallium lost its 3. Each fluorine gained 1. And we would find our formula is GAF3. Now again, that's the longer way of doing it. But again, this assignment is called Ionic Review. So now we're going to come down here and all we have to do is do our naming and our formulas. So to do this, we can see this example up top here, and I can give you any combination of these 3. I can either give you the ionic compound, so the formula, which you can see Al2O3, but what you need to know is why is it 2 aluminum and 3 oxygen? The name is aluminum oxide because that's how you name ionic. You just write the name of the metal. name of the nonmetal with an IDE. And then we have the atom addition over here, where you have to balance out the charges, right? So it's important to remember. This gives us 6 total positive, 6 total negative. So that's really what we have to do on this assignment. So if we look at this first one, I'm actually going to recommend always do the atom addition first, if it's not given to you. So we come over and we look at calcium. We find calcium on our periodic table, and we can see calcium has a +2 charge. So I'm going to write Ca +2. Chlorine has because chlorine has a -1 charge. And so we just simply ask ourselves, is this a happy compound? Do I have the same amount of positive charges as I do negative charges? No. I need more negative charges. So I draw another chlorine. Do I have the same amount? Yep, 2 positive, 2 negative. So therefore I come over here and I can say my formula is CaCl2. This next one where I give you the formula is probably the easiest. So it says CS2, so I find CS on my periodic table. CS is right here, it is cesium. So to name this, I just write the name of the metal. So cesium. And then instead of oxygen, it is oxide. And this one's kind of nice because it already tells me how many of each I need. I need 2 cesiums and 1 oxygen, so I can actually just pre-draw these out. Cesium, cesium, oxygen. And then I'll use my periodic table to find the formula, or to find the charge. Cesium is +1. And that means since these are each a +1, so I wrote that pretty poorly. Well, I can actually reason then that this oxygen must be a -2. To do the next one, indium fluoride. Again, I'm always going to do my atom addition first, so I'm going to find indium on my periodic table. I can see indium is right here with a +3 charge. And then it says fluoride. So fluorine I know has a -1 charge, so I'm going to write F -1. And again, I'm just going to ask, is that happy? Do I have the same amount of positive and negative charges? No. F -1. I need another one still, F -1. Now I can see I have 1 indium, 1, 2, 3 fluorine. So my formula is INF3. For the next one, it actually gave me the atom addition, so 3 positive charges, 3 negative charges. So in this case, Fr is francium. We can find that in our periodic table. So I can just write down francium. And then I need to change my anion, my negative charge, to an IDE ending. So I see arsenic becomes arsenide. And if you didn't get that perfectly, I'm not going to count it against you. As long as I can see you tried to change it to an IDE ending. And then I can see 1, 2, 3 francium. So my formula is Fr3, 1 arsenic, As. And then for this last one, barium nitride. Again, I'm going to do my atom addition first. I'm going to find barium is a +2. Nitrogen is a -3. So this is not a happy compound. So I look at it and I'm like, 2 positive, 3 negative, so I need more positive charges. And sometimes students feel like they made a mistake here because they're like, oh, but now I have 4 positive, 3 negative. Yep, sometimes that'll happen. So you add another negative, and now again it starts to feel a little wonky because you're like, okay, well now I just shot past it. That'll happen. 3 negative, 4 positive, so we add another barium. And hey, look at that, life is good. 2, 4, 6 positive, 3, 6 negative. So therefore, if I count, I have 3 bariums, 2 nitrogens, so our formula is Ba3 and 2. All right, there we go. I hope you found this helpful. If you have any questions, as always, feel free to reach out, contact me. Thank you for learning.